In this system's configuration, we're utilizing two separate servo motors to drive the X and X' axes. This is due to the fact that they are so far apart. If the X and X' axes were closer together, we could utilize one single servo motor with a linkage shaft between them to drive both axes. We need to do this so that the axes will move synchronously to keep the system from mechanically binding. Imagine having a large motor on the end of this actuator and a linkage shaft that acts as a coupler to drive both of these axes. What we have here is a 5-axis gantry system utilizing Parker Hannifin's HMR belt-driven actuator series. We have sizes 24, 18, and 11 of the series. Valin has sized these actuators specifically for our customer's application. In addition to the mechanics, we have even helped size Parker Hannifin's P-Series servo motors along with their PV series gearboxes. We have the HMRB series size 24 that is holding a bracket with the HMRB size 18 side mounted on this bracket. We can also do other configurations depending on your application requirements with these side mounted and this horizontally mounted, or even both side mounted depending on what your application calls for. Here we have the HMRB 18 side mounted on our X and X', and off of the HMRB 18 we have the HMRB 11 mounted straight to the axis. Here we have the HMRB 11 on this gantry system, and we've customized a bracket to hold our Stober gearbox and mount our motor to provide our customer with the Theta axis. In order for our cabling to get here, we have also included a bracket to hold our cable management system for the brake and encoder feedback cables to the motor. A very important factor to keep in mind when sizing your gantry system is the cable management and cable lengths you'll need. If you think about it, we're going to need cables to span throughout every axis of motion. Starting with the Theta, we have to go through the Z axis, through the Y, and then even through our X to get to our end. And this is because the cables are going to be bending and flexing with every axis of motion. And it's very important to have organized cables. And with these cable carriers, we're able to keep the cables organized, and utilizing high flex cables, we're able to help increase the cable's life. When doing our custom cable management systems, one of the things that we're able to account for is additional cables that our customers may have. In this particular case, we are adding extra space in the system so our customer can run air hose system to their custom end effector. The HMR series is able to come as a belt-driven actuator or a screw-driven actuator. And we know these are belts based on how the motor is mounted to the actuator itself. If this actuator was a screw-driven actuator, the motor will be mounted in line with the axis of motion right off the end, or it would have a wraparound in parallel with the axis of motion. In belt and pulley actuator applications, most of the time we have to utilize a gearbox to match the inertia that is reflected back on the motor due to the low mechanical advantage that the belt actuator provides us. If these actuators were ball screw driven, we would not be able to back drive them. But because we are utilizing belts, I'm able to move them around freely. You'll notice though, I cannot move the Z axis, and this is due to the fact that when sizing this axis, we added a brake to our servo motor. This is because this is a belt and pulley vertical application, and if there was any power failure, we'd want to make sure that the load that our customer is utilizing does not free fall with gravity. These actuators are able to come with internally mounted sensors or externally mounted sensors. We chose the externally mounted sensors with the quick connectors so that our customer can adjust the limit switches on their system. The actuators come with a T-slot so that you can adjust and move your limit switches wherever you may need them in your particular application.